Okay, so won't have a whole lot today. I don't know how far we'll get, but I know some of you do work as teachers' aides, correct? Or teachers, whatever you call it in elementary. Is that anybody in here? In the elementary? Oh, okay. So, well, regardless, maybe um, I want to ask this a certain way. I don't know, maybe we have an athletic event here, and let's say there's an elementary student sitting down at at that table in the lobby, where people may, if they have hot dogs and they want to sit at the table instead of taking it into the gym, and they're working on maybe some general information, and it includes mainly a DNA, and you just happen to be walking by. Not that you would know more about it than what they would, but maybe to a certain extent. But what could you tell me about what you know about DNA? First of all, it's deoxyribose nucleic acid, which shouldn't mean anything to you right now. I mean, that's fine. But when we talk about your individual DNA, what does that mean? We said it's what makes you basically who you are, from your hair color to your eye color, possibly your height, okay, feet size, maybe brows. Yes. Okay. Don't have anything left in the pile here. Okay. Just one person, just Adam? Anybody else? Let's try this again. Okay. So, can you tell me anything about DNA that you may know of from past experiences in life science or elementary? Yes? No? Thing? Okay. Well, once we start piecing some of this together, possibly make a little more sense, okay? So here's some of the aspects that we're talking about a 5-carbon sugar. That's where we get the idea of ribose, okay, because that is a sugar. For those of you who go on to take the organic and biochemistry class, when we get to the spring of your senior year, we start drawing out the structure of this DNA on a biochemical level. But at this point, that would not mean or make much sense to you, and neither should it. But we just break up the components to, again, just means deoxyribonucleic acid. It's made long chains of repeating units or nucleotides. And to make sense of that, okay, and what that might mean, like we said at this point, probably nothing right now, but we will try to make sense of that. Ah, here we go. This is what I was looking for. Some of you individuals have to leave. What time, gentlemen, do you leave today, football players? Oh, so we got plenty of time in here. Take your time. Maybe, maybe not. And hopefully, once we had got last chapter behind us, we just try to get through it. It's not the best of information to study, but hopefully we can make more sense of this to where hopefully something like that is more interesting. But what I want you to do is take a look at this bird as I bring it by and just think what you may believe this is. I mean, once you take a gander at it, just take a glance and then you tell me what you might think that it is. Now, see, now we got nice wide rows. I don't have to worry about tripping over someone's backpack. Okay, so I know it was just a quick glance, but when you look at this bird, what do you think it is? I already heard the answer. Not penguin. So what terms did you hear? Nope, not a finch. You got the right idea because it is a seed-eating bird. Say that again. Cardinal. But, because you would look at the beak and the crown that it has on it. Okay? It's the genetics that this has that is in its DNA that would cause this type of bird to look the way that it does. But, is this a female or a male cardinal? Well, you got a 50-50 chance. It's a female cardinal because males are what? They're all red. Okay? Now, there's a newspaper article I clipped out the picture of that. Is it possible to have a yellow cardinal? Yes, it is. But one of the things I'll read from this insert, okay? All it does is it just says in the know here in this article. It just says, in the know, last spring a male yellow cardinal with a genetic mutation that stops its feathers from turning red became an internet sensation. So somewhere along its genetic code, a mutation had taken place. So one of these individual nucleotides was out of place. And when something like that can happen, instead of looking red, it looked, yeah, I get it, this is a female, but the males would look very similar, but they'd be red in color. But for some reason, again, a genetic mutation had taken place, and it was a yellow cardinal instead of that of a red one. So, a lot of you, when you looked at that, said, yeah, that's a cardinal. So we gave two reasons. How did you know it was a cardinal? What's probably, perhaps the biggest giveaway with that? It's crown, and because we said they're what type of eaters? Seed eaters. Okay, and also for those of you who go on to take zoology, our mascot here, I can't remember, it was one of the zoology students was talking about one of these. He said, I think it was Sam. He said the wingspan on that was just enormous. Okay, so here's our mascot, which is a what? It's a hawk. Okay, here we don't even need to go all the way around the room because you can probably see from where you are sitting. But besides the size, okay, and how would you know that that's a hawk? Because, well, for one, we just told you. But there's two things that this is a raptor. Okay, when we talk about raptors, they have talons and very sharp beaks. Why do these animals have sharp beaks? So they can tear into their flesh of their prey item. I remember seeing a video on YouTube. This young little girl, she picked up this nice little rabbit because his mom had strayed away or something to that effect. So then the human mother of this little girl says, okay, there's the mom. Go ahead and turn this little baby rabbit loose. So it gets about 5 or 10 feet away and maybe about 5 feet from its mother. In comes a hawk, sweeps it away right at the last moment. And, you know, is that a sad story? Well, yeah, maybe so. But how would you look at that? That's just Mother Nature. I know. How many of you have heard of the Eagle Cam? Do you know where that's at? Decorah, Iowa, I think. Is that maybe, must be the Mississippi River runs by there. But I remember listening to the radio on coming to work. The DJs were talking about that. And, of course, the Eagle Cam is is filming down on the nest. And it must have been early on the weekend or something, and the mother came back with a rabbit, and you just see the eagle just pounding, ripping the flesh off of that rabbit to give to its offspring. So, you know, nobody said nature was kind when it comes to living in the natural order. Even genetics, I would maybe go on to say, can shape animal behavior too. When it comes to lions, okay? Do you know what lions live in? What's a group of lions called? A pride, okay? So how many females approximately would you think are in a pride? I would say probably 6 to maybe 10, okay? And that's just a guess. I really don't know. So there's 6 to 10 females, but how many males are in that pride? Just one. Just one. But then when the male, a lion that has the breeding rights, well, if you call it rights with all those females, what happens if there's a challenging male that dethrones this male, okay? So the current one is either killed or moves on because he's been, you could say, defeated. What does the new male do with all of the offspring? Just kills them. Those offspring didn't do anything wrong. You know, they're just trying to grow in the natural world. But like I said, this, again, genetics can shape animal behavior, and that's one that you would see in the natural world. Okay, so I don't mean to have depressing stories, but maybe some of you are thinking, that's terrible, little baby rabbit and... That's terrible. Talking about little baby rabbit and little baby cubs of lions. Well, yeah, that may be so. But like I said, it's a cruel world out there from time to time. So what I want to do is get through this, and then I think, yeah, this is going to be probably about as far as we're going to get. Well, no, maybe one more. Okay. Now, there's different ways that you can make an analogy here to keep this separate. At least that's what we want to try to give you. Because this will, sometime next week, will lead us into our first activity for this chapter, and that is dealing with DNA replication. man, oh man, ladies and gentlemen, what do you think? After next week, you're 25% done. Is that kind of like, come on, speed up. I want to get out of high school. It's kind of like, nah, it's going plenty fast. So medium. So not too fast, not too slow. Just right. Okay. Fair enough. Let's see here. Let's look at this one. No, we won't quite get that far. Because I want to put a diagram up on the board as soon as we're done with this information. Does everyone have this that wants it? No? Okay. Okay, so notice that it had said, so what nucleotide bonds with each other? It said adenine bonds to what? Okay, so adenine bonds to thymine. Okay, so then cytosine bonds with guanine. Now, that's something that you're going to have to know. So there's perhaps a couple different ways that you can look at that. One, you could say, I always look at it as you have to know where you're at to know if you're coming or going. Adenine, thymine, that's where you're at. If you're coming or going, cytosine and guanine. Or you could look at it this way as well. Another way I had heard is the straights bond with one another and then the curves bond with one another. That would make sense too. So either you have to know where you're at to know if you're coming and going, or the straights bond together and the curves bond together. Whatever it is that you need to do so that you know which one bonds to which. Kind of like, for instance, just a rough estimate for offensive football plays. Just throw a number out there. How many? Okay? No. How many? You open up your playbook and there's approximately how many? 25? There's more than that? Okay. And maybe there's just 25 running plays and maybe just as many passing plays. I'm asking because I don't know. Okay. So when you had to learn them plays, is it just straight memorization, or how are you looking at that to analyze, well, I need to know these plays? Do you just keep looking at them till you memorize them, or you associate the name with what direction you're going to? Because isn't it, if it's an even number play, you're going to the right? No? That's not this year? Okay. And it's no, I always thought it was funny. We were talking about this last year in zoology with Trey was in this class, Bodie, and Keith as well. And I think Keith was the first one to say, so Bodie, which way are we going, left or right? It's right. Right? Yeah, it's right. So believe what you want. I thought that was kind of funny. Can you gentlemen believe that, or do you think I just made that up? I'm not smart enough to make that up, so yeah, that's actually true. Okay, so when we look at this double helix, okay, So for instance, this is going to lead into what we would term as DNA replication. But notice that it's a double helix, and what that means is, what did it say that's actually holding these together? What type of bonds? Hydrogen bonds, okay? And we do these in three-letter base pairs, and I'll show you what that means here in just a moment. Of course, my drawings, as you can see, are just wonderful, okay? And I think I made some of them just a little bit too long. Get a little more space in here. This is something that you have room on your back page. If you feel you understand this very well, then you probably don't need to write this down. But if you're thinking, geez, this seems kind of confusing, then it would probably be a fairly good idea to write this down. So we'll just go T, A, C, G, G, C, T. We'll do this. I got Dallas on my mind. Guys would get that. Say that again. The stadium, AT&T Stadium. Yeah. And maybe some of you people are thinking, Christmas. Did the hamster stop running on the wheel upstairs or what? All right. So, as we look at that, we know what bonds with thymine. Adenine. What bonds with adenine? Thymine. Just the opposite. Cytosine. Okay. So when we look at that, the reason that that's important is this will lead into the very first part of what we call protein synthesis. The enzymes that are needed to drive the chemical reactions that if you want to say, take place in your body, that's one way of looking at it, or drives an animal's beak to look the way it does, its feet, its feathers, the color that it's supposed to be at a certain point in time, how it grows. And we said with that yellow cardinal, there was one nucleotide that was off. So maybe, like you see, that's supposed to be guanine, and then we see instead a thymine here. I'm just made that example up. Just that one nucleotide would be what we call a point mutation, because it's occurring at a specific point in the DNA. I think probably one of the biggest, what I want to say, developments as far as trying to start a family, if you couldn't or if you can't, that's for maybe someone you may know. Maybe you or your family, it's a hit TV series on NBC. You can't watch it because you usually have something going on. It's called This Is What? This Is Us. Has anyone seen or watched that show? Okay, so when we talk about Kate in that show, what's she trying to do in the show now? They're trying to start a family, but the problem is, for some reason, I don't know if she's had a miscarriage, but maybe yes, maybe no. So what they do is see a genetics counselor. There's a whole wide open field for that if that's something that may interest you. So there can also be maybe a dark side to genetics counseling too. For instance, when you go to, I hate to say like a hardware store, or just going to the supermarket and you just go to the shelf, I want this, 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 and this. This is what I want. This product, this product, this product, this product. So who's to say that you can't go to a clinic and say, I want my child to have this trait, just like your shopping list, this trait, this trait, this trait, this trait. What do you think? Is that ethically moral or is that immoral? And maybe you really don't have an opinion about that. Do you think you should be able to control what, if you wanted to have kids, what they would look like? Should you have that control? Or should it just be Mother Nature? Or the man with the plan upstairs? Or with the way this weather was, you can say maybe God's a woman. My apologies, ladies. That wasn't nice, but I just wanted to see if we're paying attention. So if that offended you, my apologies. Okay, so whether you believe in that or not, that is sometimes, you could say, the dark side of what we would consider being ethically immoral. And what about as far as taking, you could say, your DNA? I don't think there's any problem taking your DNA and replicating a liver, replicating a pancreas, a heart. You know, that's another ethics question that may have to be crossed. So if you're rich and you have the money to do that, do you think it's right that someone says, oh geez, I see people on the liver train, and it's sad. It really is. There's many people who don't get a kidney or liver in time, and maybe you know someone who has that problem. But is it right that if you have the financial means to grow your own pancreas to save your life? Is that, what do you think? And maybe you don't know, and that's an answer too. But that's possibly one of the fields of study within the next 20 years. But one of the things that we had talked about was this possible, I wouldn't say outbreak of polio, but some of these kids who are getting this AFB, we talked a little bit about that. That could very well be caused by genetics, okay? But the final thing that I'm going to show you is a lot of the students kind of got I wouldn't say a chuckle out of this, but it is quite crazy because this does have a very good, let's say, anatomy and physiology application as far as what hormones do for us, okay? And an example like that is, let's say you're pulling up to an intersection, okay? It's not a four-way stop, okay? So then you look left, you look right. I probably do it twice. But you see a car coming, and they're coming from this direction, so they got their right-hand blinker on. But man, they're moving fast. Do you turn or do you wait? You wait just to make sure. And of course, then they're probably thinking, huh, you idiot, do you think I have my blinker on for nothing? But sometimes maybe people leave their blinker on and just don't realize it. Or maybe you just, yeah, I think they're slowing down enough. But then you're starting to pull out in the intersection and think, I don't know if they're turning. And you just feel a wave of emotions go through your body just like that. I think we've probably all been there. But with this gentleman was riding a bike in, I don't know if it was a race or not. See, when it comes to these hormones, we were talking about this in the A&P class. So let me bring this up. And some people are going to say, oh, that is awesome. Other people might say, oh, geez, that's awful. Let me bring that up. Just hang on. So we got to get the full effect of the speakers. How many of you are looking at anticipation? This is going to be cool. Nobody? Because again, just think of the kind of like the turning that we're talking about. Okay. Look at this bicycler's butt here for just a moment till I get the video going. You think, ha 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 ha. Okay? You got this bicyclist just cruising on down the road. Has anyone seen this already? Some people are saying yes, some people are saying no. Okay, it's one of them things where, you know, you gotta look twice. Just pedaling along. Okay, so just think. So just think, you're just pedaling your bike along. All of a sudden, you don't even have any time to react. Okay, does anyone know what type of response this is that's called in the body? Say that again. Flight or fight. So what that means is you have some of your visceral receptors, whether it's your eyes or even inside your glands, that you see a threat coming. It's an outgoing response just like that secretes adrenaline into your blood, and all of a sudden your heart rate starts to pick up, and that's that wave of emotion that you feel go across like really, really fast. Okay? But what happens is you eventually have to have another, whether it's an enzyme and a hormone that breaks that cycle, because you can't have your heart beating like this for a long, long time. And that's why you can't just think to yourself, oh, I need to secrete adrenaline into my body. You do that, your body's going to start to fall apart at its weakest spots. Elbows, shoulders, knees, hips. One of the things you'll learn is that the human body only uses, for instance, about 20 to 25% of the actual force that you can push. So, ladies and gentlemen, you can probably do bench press, let's say, twice the amount that you do now. But there's for good reason that you can't. Because once you do that, you're starting to put a lot of stress on these weakest areas, your elbows, your wrists, your shoulders. So again, there's a reason why you can't do that at will. Okay? And just for the opposite reason, let's say for some of you people riding on the to New York City for your music trip, how many of you can't sleep on a bus to save your life? Okay? So what might you do synthetically to cause yourself to fall asleep? You take this pill. It's not a chill pill. I don't know if that's really a pill. It's a liquid, but yeah, maybe. But it starts with an M. Melatonin. You can take melatonin. Your body actually naturally secretes melatonin, and what it does is it causes you to relax. It causes your heart rate to go down. And notice that's what happens when you shut your lights off at night. Okay, there's a reason you want to keep it that way and not get your phones out and open up the bright screen. Don't do that, because it'll interrupt your sleep cycle. Okay, you might think, well, I'm usually so tired I just fall right asleep again anyway. But you're not allowing your brain to get the needed rest that it can. But, or else, if you're as fast as I am, shoot, I hit the lights and I'm under the covers before it gets dark in the room. So, what are you laughing at? That's what? Oh, I know. That's why I get athlete's foot all the time. I must be an athlete. No. Why did you have to think? No, I'm just kidding. That's good thinking. That's really good. Okay, so we will pick up with this next week.